Welcome on everyone. Let's start off. Great. Hope everyone has gone through the notes. The last thing that we did, we were differentiating a vector. Like I said, there were like 3 levels of differentiation. The first one was basic formulas, differential of a constant x power n, sine x, cos x, e power x, and ln x. And the second level was the 4 identities, f of x plus or minus g of x, product rule, and the division rule. Hope everyone has gone through this stuff. And then we did some applications based on this from light and all this stuff. Great. Let's go ahead. The next one. The chain rule. Like I said, there is one more level of differentiation, right? This is the important thing. So listen to this thing. So there is not a theory or anything. We call this thing chain rule. Again, if someone is new here, there is no need to write the notes. You will get the PDF and everything. So focus on listening, understanding, right? And I'll be giving you questions so you can answer them. That's the main focus. You will spend time more on thinking and solving. Don't worry about the notes part. You will get it. So what is this chain rule? Now, sometimes, right, the functions are not exactly the way the standard ones look like. What if you have a function inside a function? I'll give you examples. So it's like a nested function. In your computer programming, you must have done, right, a nested for loop, something of that sort. Then what you do, you differentiate this function. So you'll write this as f dash of g of x. And then whatever is inside, you differentiate it again. Yeah, mathematically, that's what it means. But let me show you an example. And listen carefully with the examples. The examples are the whole explanation for this. For example, let's say if I give you something like this, dy dx of sine x square. Look at this function. I have not taught you anything like this, right? If you see this formulas here, a is constant, x power n, this is sine x, this is cos x. So I gave you something completely weird. I gave you sine of x square. Now listen, this is how we do this. So this is sine of a function. So what is the function here? X square is your function. So when you solve these questions, right, this is what you do. First thing, what do you see? You see a sine function. So this is looking like sine of a function. Now, sine of a function, what is the differential? Cos. Remember that? So that's cos of a function. What is a function? X square. But then inside it is not x square. So you have to differentiate that function again. So this would become cos x square, and x square ka differential is 2x. So that becomes your standard formula there. So this is 2x cos x square. Let me give you more. For example, if I had to differentiate dx by x, root over x square plus 1. There is no straightforward formula for this. So what we do here, d by dx of x square plus 1 whole power half. So the first question you need to ask yourself, this is looking like what exactly? This is looking like what? Among the 6 identities that I gave you, this is looking like what? This is looking like x power n, right? This looks like x power n. It is not x power n. It looks like that. So the function here is x square plus 1. So what we do? So the function to the power of half. So it is half into the function, which is x square plus 1, half minus 1. So far, it looks like your regular formula. But inside, you don't have x. You have x square plus 1. So we need to differentiate it again. And this comes out to be, that would become 1 into root over x square plus 1. X square plus 1 ka differential is 2x plus 0. 2 will cancel. You'll get x by root over x square plus 1. Is that making sense? Right? Let me give you one more example. Listen to the example. That's the main thing. And don't worry, I'll give you some 10, 15 problems after this. So once you do that, we'll get used to it. Like I said, this is not physics. This is just a mathematical tool. So we are just learning it. We are not going to ask, okay, why is this exactly happening? Why it should happen? Let max people take care of it. Right. So our job here is to learn the tool. So others do please keep your cams on or else you'll be removed from the classroom. Let me show you one more example. D by dx of sine cube x. So what is this looking like? So the first question is always like that. Okay, this is not standard one. So this is looking like what? This is looking like sine x to the power of 3. So this looks like x power n again. But x का place में sin x था. This looks like x power n. So we will write 3 times the function by 3 minus 1. If you remember, that was the formula. N into x power n minus 1. And then differentiate whatever is inside. That would be 3 sine square x. And what is sine x ka differential? Cos x. Is that making sense, Radhika? Clear? Dave, Ahana, Ananya, Dhruv, clear with us? Shlok, Rohit? Let's take one more and then we'll go ahead. I'll give you that. What if I give you e power sine 2x? Yeah, first of all, physics me will never get a function like this, but just for fun. So again, what do we do? This is looking like e power x, but x ka place mein we have a function. So I'm marking the thing in the red. So this is looking like e power function. So e power x ka differential is e power x only. So e power sine 2x. But inside it is not x, so we differentiate sine 2x. Now this is looking like sine, but this is not sine because this is again a sine of a function. So you can have a function inside a function inside a function. You can keep doing this, right? So then this guy will be e power sine 2x. Sine 2x ka differential is cos 2x, but inside you have a 2x, so you have to differentiate it again. That would be e power sine 2x cos 2x, and the 2x ka differential is 2. So your answer is 2 cos 2x e power sine 2x. Yeah, everyone clear with the chain rule thing? Roughly getting an idea, right? So let me give you some questions. You guys give it a try, and then yeah, that's it. This is the level of differentiation expected from us, at least in physics. But any doubts on how did I do this? Please ask me if anyone is confused here. Shrikant. Clear. Great. Then let's go ahead with this. So I'll give you functions. You guys differentiate. You guys tell me the answers. You can type in the chat box if someone wants to, should here to the co-host. Okay. There are two of my logins. One is my tab. I can't see you there. The other one is my co-host. So if you got an answer, please type there if it is possible to type, so that others also can give their answers and they can try. But anyone has a doubt, anything, please unmute and always ask your doubt. Okay, don't hesitate. But if you're going to tell an answer, let others also try. You can type the answer there. So d by dx of root over x square plus x. Again, these are all the kind of functions you will see in physics. So we will do only those kind of stuff. Yeah, let's get this thing. This should take care of it. Get the first four. I'll give it 2 minutes, then I'll answer the AB2D. Everyone should try. It's completely fine to get a wrong answer, but try. And that's how you learn these things actually. If you do something wrong and when I teach you, you will realize, oh, this is what mistake I did. And yeah. Okay, people are getting answers. I know some of them are difficult to type. It's okay. Okay, let me show you the first one. Let's look at the first one. So this is looking like what? This is d by dx of x square plus x whole power half. So this is a function to the power of half. So that would be half into x square plus x. So this is looking like x power n. So half minus 1. And then differentiate whatever is inside. That is x square plus x. That would be 1 by 2 root over x square plus x. And this differential would be 2x plus 1. Right? So that would give you an answer. How much? 2x plus 1 by 2 into root over x square plus x. Please check. What is the b? Sine square 2x d by dx of sine square 2x. So this is looking like d by dx of sine 2x ka square. So the important thing is always to see, okay, this is looking like exactly what general function. This is looking like x power and x ka place may have a sine 2x. So I'm marking every time it in red, okay? So this is what I mean by a function inside a function. So that g of x was the function which is inside that f. So this is 2 into the function, which is sine 2x, 2 minus 1, and then differentiate whatever is inside. Please ask me if anyone is confused. These things are important because later on I will assume you'll know these things and then we will frame questions based on that. So, but remember again, this is sine 2x. So the simple thing, this is not sine x, this is sine 2x. So we have to differentiate this again. Basically, you have to keep doing this till you get dx by dx basically. And this would be 2 sine 2x. Sine 2x ka differential is cos 2x. And then differentiate the 2x again. You keep playing this. And the 2x ka differential would be a 2 outside. You end up with 2 sine 2x cos 2x. And I hope you remember 2 sine a cos a in 2 ways. So that's sine 4x. So that's how you report the answer there. I hope you remember that one from the trigonometry that we did in basic math. It's not in this thing. 2 sine a cos a. Any doubts on A and B? All clear with A and B? Keep going ahead. C and D are fine. They're easy. I think H is the tougher one. Remaining all are fine there. Keep going. I'll give another minute, then I'll show you C and D. Yeah, I know. It's okay. Okay, let's see. Cos 3x, and this is again looking like cos of a function. See, if it is cos x inside, one thing I'll tell you, when you're actually differentiating cos x, right, even then you're actually doing this. When you say, okay, cos of x, so differential of cos x was minus sine x, then differentiate whatever is inside. That was dx by dx, which used to become 1, so we never cared about writing it. You're getting it? So technically, if you see, we're actually doing it even for that also. We never bothered because it was always 1. So you can think of like that. So you keep doing till you end up with dx by dx. So that is one way to think of it. This guy would be minus sine 3x, and then differentiate your 3x again. The 3 comes out, and that's minus 3 sine 3x. Then sine pi by 3x plus pi by 6. Again, remember pi is a constant. It just looks weird, but yeah, it is end of the day just a number. So this is sine of a function. Sine ka differential is cos of a function. Your function is pi by 3x plus pi by 6. This is a very common differentiation, the sine pi by 3x thing. Later on, you'll encounter this in a chapter called SHM a lot. Then you differentiate your pi by 3x plus pi by 6. I'll write it down in more detail if you want the other one. So pi by 3 is a constant, so that would be dx by dx, and pi by 6 is a constant, and if you differentiate a constant, you get a 0. So this would be 0. Yeah, and you end up with pi by 3 cos pi by 3x plus pi by 6. The e part, x square plus 2 whole power 5. This is again a function to the power of 5. So this is looking like x power n. So this is 5 into the function x square plus 2 whole power 5 minus 1, and then differentiate this again, d by dx of whatever is inside. You should, right? If anyone is having trouble with this, you should definitely, redo this again. I'll send you a small sheet also. Just practice them. Like I said, it's just you need to get used to the formulas there, nothing much. Yeah, next year when they actually teach you in max, all this looks like a joke then. But till then, we need to handle this. This is 10x into x square plus 2 whole power 4. E power minus x, again, this is your function here, minus 3x. This is e power minus 3x, and then differentiate your 3x. Yeah, minus 3 comes out. This is cos x to the power of half. This is function to the power of half, and this should be half into cos x whole power half minus 1, and then differentiate your cos x. This would be 1 by 2 root cos x, and cos ka differential is minus sin x. Yeah. Please have a look at this. Any doubts so far, please ask me. Anyone not convinced with anything, not clear, looks weird, anything? And the last one we will do now. Okay, let's see. The last one. X by x square plus 1, 3 by 2. It's a very common differentiation. You'll encounter that in at least 3 chapters. X square by x square plus 1 whole by 3 by 2. Now, see, this you can do division rule. Again, my personal preference, I don't like division rule. I never use division rule. For some reason, I hate it. So what I do every time, I always use the product rule. So d by dx, I write this thing as x power 1, and I write this thing as x square plus 1 whole power minus 3 by 2. Right? If you give me even, let's say, something like, 1 by cos x or secant x, I do that only. Secant x, I will write it as 1 by cos x, and then I'll write that as cos x whole power minus 1. I can do everything with the division rule, product rule. It's an unnecessary waste of time to remember one more formula. As simple as that. If I can do with product rule, I'll do it. This is something, I always did in 11th and 12th. If I can derive something in 45 seconds, there's no need to remember. At least that's what I used to say to myself. It worked. So yeah, product rule. So we have two functions here. This was your f of x and this was your g of x. So you know what to do. When you differentiate one guy, the other guy waits outside. So this is x square plus 1 whole power minus 3 by 2, and then differentiate that f of x plus, and then when differentiate x thing, so this would be d by dx of x square plus 1 whole power minus 3 by 2. Now I'll do one thing. I will just differentiate this guy first separately, and then we can just put it there. So this is looking like function to the power of minus 3 by 2. So this is minus 3 by 2. X square plus 1 minus 3 by 2 minus 1, and then differentiate whatever is inside. That turns out to be minus 3 by 2 x square plus 1 whole power 5 by 2, and that's 2x plus 0. That would be minus 3x by x square plus 1 whole power 5 by 2. Perfect. So when you substitute this thing here, that would be 1 by x square plus 1 whole power 3 by 2 minus 3, and there is an x sitting here already, x square by x square plus 1 whole power 5 by 2. You can actually simplify this further. If I take out x square plus 1 whole power 3 by 2 common, this becomes 1 minus 3x square by x square plus 1. And then when you shift it there, you'll get x square plus 1, and that would be minus 3x square. So that would be minus 2x square plus 1 by x square plus 1 whole power 5 by 2. That's your final answer, everyone. Now, no one is going to ask you like this in the exam, okay? What they're going to ask you would look something like this. Mm-hmm. There. Can you see this function here? You will see a functions like this. X by x square plus 3 by 2, and also then we had to do something called maximum minima. So you will encounter things like this. Like I said, this is a tool. It will come somewhere. This is not the direct thing anyway. But anyway, so if you got all these 8 questions, I think your level 3 of differentiation is good. Any doubt so far? right? So it's fine. Sometimes you'll still do one or two mistakes there. That is okay. You'll get the hang of it. It'll take time, but definitely make sure to revise this after the class gets over today or tomorrow. Great. So let's see some problems based on this. That's it. So last class was dv by dx. So when to use which one depends on what you're giving. If you have given me the velocity in terms of t, I'll use dv by dt. If you give me velocity in terms of x, I'll use v dv by dx. Right? So great. Let's do a question on this then. So let's say x is equal to 1 by root over t plus 1. Find velocity at t is equal to 1 second. Yeah, let's get this thing. And we'll bump it up slowly. My voice was lagging here. Is my voice lagging, everyone? Is it fine? It's fine. Okay. I think maybe for some of you. Ahana, is it better now? Okay. Okay, then fine. And I've been actually out actually. I came to my hometown, so net is a little laggy here. Tomorrow I'm back, so it should be fine. Finish off easy one. It's just a single differential there. Okay, let's see. Okay, let's see. So you want velocity? It is simply dx by dt. So that is d by dt t plus 1 whole power minus half. So this is looking like a function to the power of minus half. So this would be minus half, the function which is t plus 1 whole power minus half minus 1, and then differentiate whatever is inside. This will be minus by 2 t plus 1 whole power 3 by 2, and that's 1 plus 0. That's minus 1 by 2 t plus 1 whole power 3 by 2. You're asking a t is equal to 1. So if you put t is equal to 1 here, I end up with minus 2 by 2 power 3 by 2. Or you can write that thing as 4 root 2. Yeah, easy. Great. Next thing. So let's bump it up a bit. Let's say velocity v is equal to root over t square plus t. T is time here. Velocity v is a root over x square plus x. X is your position here. Find the acceleration in both the cases. Again, be careful. Both of them might look same, but one is depending on time and one is depending on position. And then the formula will change. A we write as dv by dt if you're going to be in terms of time, and A is v dv by dx if your v is in terms of x. So without noticing that, if you use the thing, yeah, people do that in a hurry exam mein, so be careful with that. Sometimes people like, oh, itna silly mistake count karta hai. When you're in exam in 3 hours, right? 12 minus 8 becomes 20. Your senior did last year, the guy who got 600 ranks. So my favorite mistake was 3 into 3 is 6. So I did that in my final chemistry paper also. So kya kare? Everyone has their own favorite set of mistakes. Okay, Prisha got something. Anyone else? Okay, second one looks easy and good. I'll give another minute, then I'll show you. Let's see. So acceleration is dv by dt here. D by dt of t square plus t whole power half. So this is looking like a function to the power of half. This is half into the function, which is t square plus t whole power half minus 1, and then differentiate whatever is inside. This would be 1 by 2 root over t square plus t, and this guy would be 2t plus 1. 2t plus 1 by 2 into root over t square plus t. That's your answer. So here, the second part is v dv by dx. So for convenience, what we'll do now, first let's find dv by dx. And then we will substitute there, right? So let's find dv by dx. Now, if you actually see, right, they are one and the same thing, isn't it? dv by dt, dv by dx, x ka place mein t, you can say it's going to be the same answer here, bas x replace kar lo. But okay, we will do it. If you see, all the steps would look exactly same, x square plus x whole power half. That would be half into x squared. So now these things, right, should get used to it. Maybe after 1 or 2 classes, these things I'll just directly write it down and I'll expect you will know this thing. So make sure to practice it. They're not tough, but just redo them again once more. That should be sufficient. 2x plus 1 by 2 into x square. Yeah, you get the same thing here, x square plus 1. But remember, this is not the answer. This is just dv by dx. The acceleration was v into dv by dx. So we need to multiply that again. So root over x square plus x. 2x plus 1 into 2 into root over x square plus x. Yeah, so this and this will get cancelled out and you end up with 2x plus 1 by 2. Please check your answers. Any doubts on the steps? So if you see, right, all these problems are part of something called kinematics, which we are going to do next. But these are all the tools. That's what I'm saying. No one is going to ask you find differential of that, find differential of this. These things will all come with a combination of something else. It's like a tool. That's it. All clear with this? Ananya, clear? Trisha, got the second part? Yeah. The denominator of the 10th is 1, or that is t. I don't know why I wrote 1. My mistake. Radhika, clear? Shlok, Shreya, Soumya, clear with this? Great. Let's bump it up a little more. Let's say you have a vector r bar, which is sine 2t I cap plus cos 2t j cap. Last time we did differentiation of vector, find v bar and a bar, the velocity and acceleration. And how do we differentiate a vector? Last time we discussed that. So when you want to differentiate a vector, you simply differentiate I ka coefficient, j ka coefficient, k ka coefficient, and just put your I, j, k as usual. So it's really not that different, except now you have an I, j, k on the tail. Hmm. You got an answer. You can type here, I think. Anish got it. I think this is an old Zoom, I guess. Try everyone. Another 45 seconds, and I'll show you. Remember, it is sine of a function. So you have to differentiate the 2t again. Okay, let's see the velocity v bar, which is dr bar by dt, which is this is sine ka differential, d by dt sine 2t I cap. I'll show you a few of them. Takes time little to get used to it. Right, so this is sine of a differential, so that's 2t and 2t. So sine ka differential cos 2t, but then you differentiate whatever is inside. That's 2t co-differential. Wapas again you have to do it. Cos ka differential minus sine 2t, then differentiate whatever is inside. So basically you keep differentiating that 2t every time. Simplify this, you end up with 2 cos 2t I cap minus 2 sine 2t j cap. You do this again. This is your velocity v bar. If I do it again, acceleration, by now I hope you got the hang of it. So this 2t, every time you differentiate, it keeps coming out. So I'll write down directly now. So 2 cos ka differential minus sine 2t, then differentiate the 2t again, that will give you one more 2. I hope that was clear. If someone is confused, please ask. I skipped a step there. Sine 2t ka differential is cos 2t, then differentiate the 2t again, that gives you 2. That's your j cap. Then multiply this thing. So this is minus 4 sine 2t I cap and minus 4 cos 2t j cap. Anyone not clear with this, please ask. All clear with this? Next one. Let's say x is equal to b into t plus e power minus kt. B and K are constants. T is time. Find velocity and acceleration. Find initial velocity and initial acceleration. Again, what is the meaning of initial? Initial meaning time zero. So they won't say find velocity and acceleration at in t0. They'll simply say initial, and you have to understand he's talking about t0. Initial implies t0. Last time we did something like this, but yeah, now you can handle it. Okay, Prisha got something. Anish got the velocity part. Anyone else? Rohit. Dhruv, you have to keep t0. Right? How are you even ending up with exponential? You can't get it. Shreya, you got B plus 1. Okay. You didn't get a minus sign. You should get a minus sign. Because that e power minus kt minus k बाहर आता है, right? Okay, let's see. So, velocity dx by dt. For simplicity, let's write this thing as bt plus b into e power minus kt. So this will be b differential of t. B is a constant, you can just throw it out. D by dt e power minus kt. So the dt by dt is 1, and e power minus kt. Remember, this is a chain rule again. This is e power something. So e power function. So that would be minus e power, the function. Then differentiate that function again. That would be b into e power minus kt, and you end up with a minus k there. So you get velocity v is equal to b minus bk e power minus kt. You want acceleration, differentiate this guy again. That would be dv by dt minus b and k, both are constant. D by dt of e power minus kt. B is 0, this is minus bk. You end up with e power minus kt, then differentiate that kt again. Right? Exam you should not be writing these many steps. You should learn to skip. Yeah, but anyway, class notes, it is fine. So that would be like a minus k e power minus kt. This would be bk square e power minus kt. This is your acceleration. Perfect. So what do you want? Do you want to find them in t is 0? No, just dump t is equal to 0 at the end now. At t is 0, when I put that, you'll end up with b minus bk. Remember, e power 0 is 1. Acceleration will be bk square. Check. All clear with this? Nah, I didn't give the exact one. Remember? यहाँ पे T नहीं था. There is no T here and there is a minus sign here. That was 1 minus e power minus kt. I gave that, no, but that time I didn't teach you the chain rule. So clear with this? Great. Now let's do something better. Any doubts on this? Any confusion on this exponential stuff? Clear, na, Rohit? Dhruv, I can't see you. Your cam is blank. Wait just it. Perfect. Let's see how they can frame an advanced question. Like I said, pure vectors or calculus, they really can't ask advanced stuff, but we can play a bit. So this particle here is going in a circle with speed u. So this is the scenario when t is equal to 0. So after time t, you would be somewhere here. And this would be your position vector, r bar. We have done this also before, in finding the position vector. A particle moves in a circle of radius r with constant speed u. As shown. So initially it is starting on the x-axis. Find r bar, the position vector, as function of time t. Find v bar, the velocity, as function of time t. Find acceleration as function of time t. Right? So that is the starting part. This is not the actual question, but we need this for the actual question. So let's get this first of all. So you can see now what is happening as the particle is traveling here. When it is here, this is the position vector. When it is here, this is the position vector. So your vector is continuously rotating. So as time passes, your rotate vector is also going in a circle round, round, round. So let's find r bar as function of time t. So your answer should come in terms of t, u, and r. This is the third time you're actually seeing this. First time, if you remember, we did this thing in the Cartesian and the polar coordinates. Second time, we saw this in the position vector. It's the third time. Think. Let's get an r bar. So basically, you have to do this thing, isn't it? After time t, it will make an angle theta. We drop this thing, we get your x coordinate, we get the y coordinate. So xi cap plus yj cap. You need to get theta. Find theta in terms of time, and then you're done. You'll get x and y coordinate, and then differentiate 2 times, you'll get velocity and acceleration. So that's how the whole thing is connected. Get the coordinates, get the vector, and then differentiate. Vectors and calculus. So how do we get theta? So if this is your theta, so this particle here is traveling on an arc length. How much is this distance? In time t, you will travel a distance of speed into time. And if you remember, this is the whole definition of theta, the arc length by radius. This is the first thing I taught you. Which is ut by r. There I got theta as function of time t. Once I got this, it's straightforward after that. Drop a perpendicular. This would be your x coordinate and this would be your y coordinate. So we can clearly see x is equal to r cos theta and y is equal to r sin theta. You're done. So what's the position vector? R bar is xi cap plus yj cap. So your position vector would be r cos theta is ut by r I cap plus r sin ut by r j cap. Have a look at this. This is your position vector. Now, how to get velocity? Differentiate it. You want acceleration? Differentiate it 2 times. Can you get that? Try. I'll give you a minute more. Now it is just a matter of differentiation. Now, if you look at this question, this thing looks exactly like this guy, sine 2t and cos 2t. Here it is all just variables. So it looks a little weird and all, but it's the same thing that you're doing. Hmm. Yeah. Try. We want another 40, 30, 40 seconds. Okay, let's see. So let's differentiate this. So remember, every time you differentiate this ut by r, also you have to differentiate. So you just keep throwing one u by r outside basically. So v bar r differential of cos is sine of ut by r. Then differentiate whatever is inside. So the variables, right, will look a little weird and all, but you need to get used to these variables. It is just a number. U by r is some number. That's it. I cap plus this is also r sine ka differential. There is a minus sign here, and this would be cos ut by r, and then differentiate that ut by r again, and then you're left with a j cap. So ut by r ka differential is u by r, which comes out. So that would be minus u sine ut by r I cap plus u cos ut by r j cap. If you differentiate this again, dv by dt, this would be minus u sine ka differential is cos ut by r, and 1 u by r comes out. So I'm skipping that step now. Cos ka differential is minus sine ut by r. 1 u by r comes out. Now this thing would become minus u square by r. Cos ut by r I cap plus sine ut by r j cap. And if you notice this, what is this exactly? Here, if I take r cap, so see what is mod r bar? Mod r bar is r only, the radius of the vector. So r cap will be r bar by mod r. That turns out to be cos ut by r I cap plus sine ut by r j cap. And if you notice this, this is actually a bar is equal to minus u square by r cap. So it's like, I don't know, in school, did you study anything like this centripetal acceleration? That's u square by r minus r cap. Right. So if you have studied in school, it's okay if you didn't study about it, but if you have studied something like that, there's something called centripetal acceleration. When a particle goes on a circle, there is an acceleration towards the center, which is equal to u square by r. So we indirectly proved it actually. When this guy is going in a circle, there's an acceleration towards the center. So there's a name for this. It's called centripetal acceleration. Don't worry too much about it. We're going to do it again in circular motion, but in case you know, then it is fine. So the minus r indicates it is towards the center. All clear with this? And there's something more also, if you have noticed it clearly. Any doubts on this page? Can I go ahead? Radhika, Dave? Clear? Soumya, Shriya? Rohit, Shlok, Shrikant? Now see, if you notice something here, when this thing is going in a circle, look at this carefully. This vector was your r bar. Great. When you differentiated it, you got velocity, which was tangential, v bar. Let's write it like this. So this is dr by dt. When you differentiate it again, you got an acceleration, which is actually the double differential, d square r by dt square. So if you notice something, every time I differentiate, the vector is actually rotating 90 degrees clockwise. Did you observe? First time I differentiated, r became v bar, it rotated 90. I differentiated again, it rotated 90. So from this, I'm getting a feeling if I differentiate again, I should get maybe vector like this. So this vector, the differential of a vector is also rotating 90 degrees. Every time you rotate, it's rotating, right? So something like that is happening here. So we can prove that also. So that is something to think of, right? So we will be making a question based on that next after the break. So take a break, come back by 9:40. We'll continue from here. It is not universal. I'll show you. It happens for a special case. Any doubt so far? No. Let's go take a break. Go away from the screen for 5 minutes. Okay, come back by 9:40.
Recording in progress.
Yeah, let's start off. Thanks on everyone. So this thing, right, rotating. So when does this happen exactly? Let's prove it and then we'll see. Let's say if you take a vector of constant magnitude. So first let's go pure max and then we will try to interpret it. Now see, the vector with a constant magnitude, it's not a constant vector. When you say constant vector, the direction and the magnitude both cannot change. But here the magnitude can remains constant, but the direction can change. Comes on everyone. So let's say the vector is a bar. So mod a bar is constant. Now this can be written as a bar dot a bar is also constant, because if I write a square is constant, a bar dot a bar is constant. Differentiate on both sides. Differentiate with respect to time. Now this is a bar dot a bar. This is like a product rule, isn't it? There are two of them. So when I differentiate one guy, the other guy stays outside. And remember, you can differentiate even with a dot product. The same thing, when you differentiate the other one, a bar will be outside. So since both are same, they will look the same. But what happens to the right hand side? The right hand side is a constant, which becomes 0. So this comes out to be 2 times a bar dot dA bar by dt is 0. So we got a bar dot dA bar by dt is 0. But we know from vectors, if dot product is 0 means what? The vectors are perpendicular. Since the dot product is 0, we can say a bar is perpendicular to dA by dt. That's the reason every time when you differentiate, you're rotating 90 degrees there. And why is the vector constant? Because think about it. When you're going in a circle, isn't the radius of this vector constant every time? The direction was changing, but the magnitude is not changing. Now, that's the mathematical thing, okay? You can prove it with a dot product. But how do we interpret this geometrically? So we can write like this: if a bar is perpendicular to a bar, if mod a bar is constant. This would be good theoretical questions. Okay, now let's try to interpret this geometrically. Anish, Dhruv, comes on. It's easy to understand in terms of geometry. Think about this. When you say a vector is changing, see, when you say dA bar, it simply means the change in vector. Interpretation. So how do you change a vector? Think about it. You can change a vector by changing the magnitude, or you can change a vector by changing the direction. So if you have a vector a bar, either change the vector by increasing the length. So let's call it delta parallel. So this thing will change the length of the vector. You stretch the vector or compress the vector. Delta A parallel, I'll just put 2 parallels there. This is responsible for changing magnitude. This is going to stretch the vector or compress the vector. The other one is delta A perpendicular. This is responsible for changing direction. Now, generally vectors both will happen at the same time. Your magnitude is changing, your direction is changing. So yeah, it works out. But now you're saying the mod A bar is constant, meaning you're saying the magnitude cannot change. Then you don't have an option, right? Then there is only way since the magnitude is constant. Tanvir. Tanvir, got something? Same thing, what we proved mathematically with the differentiation, we're trying to interpret geometrically. Since you're saying since magnitude is constant, delta A parallel must be 0. That means only thing that is left is delta A perpendicular. Since magnitude is constant, only delta A perpendicular exists. That is the reason the change in vector dA bar by dt is perpendicular to A bar. Think of like this, okay? If you stretch your hand, right? And if I tell, think of like this thing. Let's say you're standing here, your friend is standing here. This is the condition I gave you. The distance between you and your friend is constant. But you saw your friend moving. How is that possible? The distance between you and your friend is constant. That cannot change. But you're saying your friend is moving. The only way that can happen if they go perpendicular to the rock, isn't it? They're basically going in a circle. Is that making sense logically? If the distance between you and me cannot change, but I see you moving, that means you're going in a circle. There's no other option only. And if you're going in a circle, that means the distance between you and me and your speed both should be perpendicular. All clear with this? So basically from this idea, right, when you take a vector, patience, Rayana, patience. If you have patience, you will see everything. So this was your R bar. This is what we call velocity. I'll not call it velocity. I'll just call it dr by dt. Right? If I differentiate again, this will be d square r by dt square. So for convenience, what? Let's do one thing. Let's call it R1. Let's call this thing R2. If I differentiate again, this will be d cube r by dt cube. This will be R3. If I differentiate again, this will be R4. If I differentiate again, this will be R5 and R6 and so on. You're getting it? Every time you differentiate, the vector keeps rotating 90 degrees clockwise. So if I differentiate this again, so this would be d power 4 r by dt power 4 and so on. So that's the idea there. So when we differentiate a vector with a constant magnitude, it rotates 90 degrees anti-clockwise. If you see, it's rotating opposite to the clock. How is this related to the previous one? Isn't the previous vector which we got, isn't this a vector of a constant magnitude, Ahna? Can you see this R bar? Does this length of this vector ever change? No, right? So when you differentiated first time, आपको क्या आया था? You got velocity. When you differentiate second time, you got acceleration. And how are the velocities? Look at this. The position vector, the velocity, and the acceleration every time are in the rotating 90 degrees. Right? So we got this, but we generalized it. So the magnitude of this vector is nothing but the radius of that circle. Is that making sense? So here, if you see, in this question, we stopped only with two differentiations, right? R, V, and A. Now I'm saying you can differentiate it 10 times and it will still keep doing this. Make sense? All clear with this whole story, what we did? Now the question. So the same question, there'll be a second part of it. If U is equal to 1, R is equal to 1, find modulus of dr by dt plus d square r by dt square, the second differential, d cube r by dt cube, third differential, and so on till d 2001 r by dt 2001 come magnitude. So I took this vector, I differentiated them. What is this year? 2026 now. We can do that. 2020. We'll keep it little simple for you guys. How much should I give? And I'll give 2021 only. So you took a vector, you differentiated it 2021 times, then you added all those vectors, and then you got a magnitude. How much is that? Think of it. There are more ways to play with this, but yeah. With all the story that I told you from the last 15-20 minutes, it is for this part. U is 1, R is 1. Think. Take a minute or two. It's a good one. Think about it. It's completely fine if you don't get it also. I want you to try. Okay, Shlok says 0. I don't know. What about others? Let's see. Others try. Ahana says sine. Ahana, if you see, I kept a mod over the whole thing. Matlab, end mein you had to give me the magnitude. So sum of all the vectors, uska magnitude. And Ananya also says 0. Okay. I don't think so. It's not 0. Itna to pata hai. Ne Rohit, again you have to give me answer, Rohit. What is theta? Theta to diya nahi maine. You'll get a number. That is the best part of the question. Okay, Anish says something, 1. So we have 0, we have a 1. What else? We have 2 1s and 2 zeros. Anyone else to tip the balance? We have 3 1s, so yeah. 1s are dominating. 4 1s, I think. Yeah. Let's see what is happening. Suno. I said U1, R1. Now, notice something here. When you say U1, R1, this was the vectors here. Basically, the magnitudes all became 1. So, R bar was simply R cos whatever is that ut by R I cap plus R sin ut by R j cap. U is equal to 1 and R is equal to 1. So your R bar was simply cos t I cap plus sin t j cap. And when you differentiated this V bar, you ended up with minus sin t I cap plus cos t j cap. When you differentiated this again, you ended up with minus cos t I cap plus minus sin t j cap. If you notice something here, the magnitude of R bar was 1. Magnitude of V bar was 1. Magnitude of A bar was 1. Matlab, You keep differentiating this, you end up with always 1 only. Because sine square t plus cos square t is 1, right? So what we got here is a vectors which are rotating 90 degrees and all of them are ones. Means no matter how many times you differentiate, you're going to end up with 1. So those are the few things we can see. So first thing, the magnitude of all differentials is 1. Easy by keeping u and r is equal to 1. So magnitude of all differentials is 1. And all these differentials, right? And every time you differentiate, rotate by 90 degrees is 1. Second thing, they rotate by 90 degrees when we differentiate. Perfect. So yeah, done. So the first differential would be dr by dt. I'll call it R1 for simplicity. Then this would be your R2, this would be your R3, and this would be your R4. Did you notice something? If you take a set of 4 vectors, won't they cancel out? R2, R4 will cancel, R1, R3 will cancel because they're opposite. So basically set of 4 vectors cancel out. Right? So the next set would be R5, R6, R7, R8. That also will cancel. I can do this so on, and I think NMA I would end up with R 1996, R 1997, 1998. I need to do it. This is 7, I guess. This is 7, this is 8. This is 1999, and this is R 2000. That also will cancel. And NMA you will be left out with R 2021 दिया ना? ठीक है, I'll change the question. Who will write all that now? Let's make this thing 2001. It doesn't matter. It is the same thing. It's a factor of 4th, always cancel out. And you're left with 2001. Make sense? So these 4, 0, 0, 0, 0, 0, and you're left with what? 1 vector. And what is the magnitude of this vector? 1. So when you added all of them, 2021 vectors or 2001 vectors, 2000 vectors got cancelled out. And what's left is 1 vector. Is that making sense, everyone? So when you did all that sum, dr by dt plus d square r by dt square, so on. So you are just left with dr 2001 by dt 2001. This is as good as 2001 ka 1 vector, whose magnitude is 1. All clear with this? Now you can play with a little more variations on this. What if I ask you this one? dr by dt plus d square r by dt square, so on till d 2002 r by dt 2002. What do you guys think? dr by dt d square r by dt square, so on till d 2020 2003 r by dt 2003. dr by dt by d square r by dt square, so on. Basically everything, right, can be grouped into these 4 categories. What is this? That's it. These are the 4 questions you can ask, because everything else is a combination of these 4. What are the answers for these? Just give it a try. I'll just get some water and cup. So from the previous logic, you must have guessed it now. Basically, four vectors will cancel out. You won't get 3, right? 2 भी नहीं आएगा. How are you guys getting that? Okay, see, when you say 2002, right? 2000 तक तो सब cancel हो जाएगा, right? So let me just rewrite this. So we know till 2000 will everything will cancel out. So this is simply dr 2001 by dt plus, I'll just write this as r 2001 plus r 2002. So think about this, okay? How will these two vectors look like? R 2001 will look like this, and R 2002 will look like this. And both the vectors are perpendicular. If two vectors are perpendicular and the magnitude is 1 and 1, what is the magnitude? 1 I cap plus 1 j cap ka magnitude is how much? √2, isn't it? If you have two vectors perpendicular to each other, 1 and 1, what is the magnitude of these two vectors? √2. It's not 1 plus 1, right? The vectors are not in the same direction. Are you clear with this? इसमें क्या होगा 2003 में? You can guess this also. This will be 2001. This will be 2002, and this will be 2003. So you can clearly see 2001 and 2003 will cancel. 2022 will be left. So this is 1. 2004 is a factor of 4. So all will cancel out. This is 0. So you can get only answers 0, 1, √2. That's it. You can put 1 million vectors and it still doesn't matter. All multiples of 4 will cancel out. Is this making sense, everyone? There, see how we played the whole game. We started with the position vector r bar that comes from just coordinates. When we differentiate, we got v bar, then we got a bar, and then we noticed these things are perpendicular, and then we thought, ऐसा क्यों हो रहा है? And then we said, okay, is this only for this circle thing? Then we said, okay, actually for any circle basically, right? If you have a magnitude of a vector of a constant magnitude, when it differentiates, we proved mathematically it is perpendicular. But yeah, max is max. But what does it even mean? So we tried then geometrical interpretation. We said when a vector changes, it can change only in two ways. Either change the length of the vector or change the direction. But since you gave a condition, don't change the magnitude, the only thing left was the direction. And then the only possible way is to move perpendicularly. So we proved it in two different ways, right? And then we said, okay, so every time you differentiate, you're rotating by 90 degrees. And what about the magnitude? Technically, the magnitude increases every time by u by r. But to keep our life simple, because I wanted to cancel out, I gave u1 and r1. Once I did that, suddenly things became pretty straightforward. We observed every time you differentiate, vector rotates by 90 and magnitude remains 1. But when you see differential of 2001, people first thing they'll see and they'll get like, what the hell is this? So this is more of a shock factor. And these things, you should get used to it in advance. They do this a lot. Most people see the question, they panic and they're like, what the hell is this? That is okay. First think, what the hell? And then think, okay, if the examiner is given, maybe there's something I can think of. But anyways, you'll get used to it. All clear with this? It's a worthy equation. If you see, you learned a lot of things here. Like we learned vectors, differentiation, and then we did all this stuff. So anyways, all this will go under one question, 13. So quite an important one. Should definitely revise the whole thing. When I say revise, don't read it like a novel. Take a rough paper and try to resolve. If you take r is equal to 2, then we have a problem. We have a big problem. If you say you will take r is equal to 2, what about u? You also have to take something. What do you want to take U? If you take U is also 2, then you're safe. But if you take something else, you are dead. For simplicity, ऐसे ले लेते देखो. Let's say R is 1 and U is 2. ठीक है? Every time you're getting multiplied by U by R means every time you're becoming double. You know what's happening to your vectors? So initially vector is 1. Next vector was 2, rotated 90 degrees. Next vector was 4, rotated 90 degrees. Next vector is 8, rotated 90 degrees. So these things are becoming bigger and bigger and bigger, isn't it? They won't cancel na abhi. Dekho, set of 4 vectors, will they cancel? They won't cancel. So it won't be so easy like what I said to do. So we can't solve them. Can be done, but yeah, that's not the point. You're not a max class, right? That becomes more of a max question. So we got the point. Differentiate karo though, it will rotate 90 degrees. That's it. That's the main idea I want to teach you. All clear with this? We'll go ahead. Any doubt so far? Great. Next thing, the rate of change. So whenever something changes with time, we call it as a rate of change, right? So when you hear this word rate of change, this implies, the quantity is differentiated with respect to time, or the quantity is compared with respect to time. And example, think of like this. They will say something like this, a disk of radius 10 centimeters, right, has its radius. I can say like this, a disk, the radius of a disk increases at a rate of 1 centimeter per second. So the meaning of this statement, right? Indirectly, he's telling you the radius d r by dt is 1 centimeter per second. That is the verbal way of saying the rate of radius is increasing at rate of 1 centimeter per second. Then the question would be something like this. Find the rate of change of area. So if the radius of the disk is increasing, the area is also increasing. Find the rate of change of area when the radius of the disk r is 10 centimeters. So what is he asking you again? When you say rate of change of area, he is asking you to find dA by dt. So listen to this, I'll show you one question. So first thing, area of the disk, let it be A, which is pi r square. And you want to differentiate with what? You want to differentiate with time. But here area is depending on what? R. So when I differentiate dA by dt, now listen carefully here. Pi is a constant, comes out. This is d r square by dt. Now tell me one thing. This thing, does it look, is this a t square? No, right? It is r square. So this is pi into, so d by dt. This is r ka square. So this is like some function to the power of 2 because inside it is not t. Then it is pi into 2 times r, then whatever is inside it, differentiate it. Chain rule. Basically, you'll be stuck there. Getting it? You can't simplify it further. I'll show you another way if you are not happy with this. So the dA by dt is 2 pi r dr by dt. You're done. You got it. 2 pi. What is r? He said find the rate of change when r is 10 centimeter. So this is 10. Dr by dt, that is 1. So that is 20 pi centimeter square per second. So when the disk radius is increasing at 1 centimeter, the area is increasing as 20 pi centimeter square. Now, if someone didn't like how I got this differential, then another way to do this is this. We got area is pi r square. Do your normal differentiation dA by dr. This would be 2 pi r. Send dr that side. then divide by dt. If you show this to the math teacher, he'll punch you. Getting it? But physics mein chalta hai. Happy? You can do this also. You can do this also. This is mathematically more accurate. This thing, it works. All clear how we did this? So these are called rate of change. So when something changes, we want to know how the thing gets affected. So let's do a question on this and then let's see. So slowly if you see, right, the differentiation is actually the easy part. The headache is always converting a verbal problem into equations and solving. Next class when we do, right, we are going to do something called maximum minima. You will see even more of this. So let's see. The side of a cube is increasing at a rate of 2 centimeter per second. Find rate of change of surface area and volume. When A is equal to, when the side is equal to 20 centimeters. There, same question, I just changed the shape and the values there. So when the side of the cube is 20 centimeters, find the rate of change. So let's get this. Again, I keep telling you, definitely please revise this within 24 hours. Right? You open these notes after 3 days and then you see this, everything will feel like, I have seen this somewhere. It looks like your long lost friend. Nothing will go into the head. And it is not your fault. Human brains are designed to forget things because if you remember every damn thing in your life, you'll make your life miserable. So that's your brain function to forget. I told you this last time also. There was a study done in some Harvard or Princeton, I don't remember. But what they said, whatever you study, right, after attending a class, within 24 hours, it decays to almost, 90% decays. Nothing is left actually. So what they suggested is if you can revise within 24 hours, the earlier, the better. Then you bring it back to 100. It won't stop. It continues to decay, but this time it takes a week to decay. Then you need to revise again within a week and bring it up again. And this time it takes 6 months to decay. So basically the duration goes up. I think roughly you need to revise everything at least 4 times. So next day, 1 week, and maybe after a month or 2 months. So. And trust me, don't think like, "Arey yaar, count karega." If you don't spend the 20 minutes to revise, trust me, after a month, you'll spend 3 to 4 hours. So you're actually wasting time, which you don't have. Most people don't understand this. उनको लगता है मैं सब एक साथ कर लेता हूँ. Or you are confident, like, you overestimate yourselves. Don't do that. Right? Be very clear, you're going to forget it. So, end of the day, like, I'm telling you, not like a teacher, but as a person, right? Even I wrote the exams. People do that mistake. They think like I will do everything together. It doesn't work. You need to revise. Whatever I taught you, right? Just take a paper and try to solve it again tomorrow morning and see, you will understand. Some of the things, you won't get only. You'll feel like, okay, what did we do exactly? So what do we do here? So let the side of the cube be A. So what is given in the question? They gave you dA by dt. He said the rate of change of side is 2 centimeter per second. Perfect. You want surface area. The surface area of a cube is 6 times a square. Hope everyone remembers that because there are 6 faces. So let's call it area is this. So 1 dA by dt. That would be 6. A square ka differential. A square ka differential is 2a. But that is a there. So we have to differentiate a again. That's it. You can't simplify that. You have to leave it like that. And you're done. So how much is this? 6 2s are 12, A is 20, and dA by 2 is 2. That's 12 to 24, 40, 480 centimeters square per second. Same thing I can do for volume. So volume V is A cube. Q1 dV by dt. A cube ka differential is 3 A square, and then differentiate whatever is there, the function dA by dt. That's it. You're stuck there. So Let's see something even better. So this rate of changes, right? It's not always about volumes. You can play around. Let's say we got a cone, right? And the cone is filled with water. And this half angle here is 60 degrees. So the cone ka thing is 60 degrees here. This is the height, h is the height of the cone. L is the slanting length. H is the height of the cone. Or you can say actually height of the liquid. So this H is the height of the liquid in the cone. So L is also that slanting length of the liquid. Perfect. Now what happened? This is an inverted cone filled with liquid. There was a small hole at the bottom and the liquid started leaking. The liquid leaks at a rate of 10 centimeter cube per second. So this is constant. So every second, right, the water is continuously leaking out. And then what will happen? The height will change and the length will change, isn't it? So we need to find the rate of change of height. Find the rate of change of height. So indirectly, what I'm asking you is dH by dt, meaning how fast is the liquid level dropping when the slanting length L is 3 centimeters. So as the liquid is going out, do you all agree the water level will continuously keep decreasing? So with what speed is the water level coming down when the liquid is leaking at a rate of 10 centimeter cube per second? You know how they can ask you this question another way? They will say there is a piece of paper on the liquid. So if the liquid is coming down, the paper also will come down. So he's asked to find the speed of the paper piece, which is the same as dH by dt, isn't it? The rate at which the height is falling is the speed of the paper. So yeah, it is just a way of asking differently, but that's what indirectly being asked. Everyone knows the volume of a cone, right? In case someone doesn't know, volume of a cone is 1 by 3 pi r square h. R is the radius and h is the height. You will need that. Let's see how will you handle this. Again, all these things are, I won't say they're difficult, but these all are different problems getting it. So if you're not getting them on the first try, don't panic, don't worry. It is pretty normal. So the point, think of it like this, instead of thinking, "Arey yaar, ye kaisa karenge?" Think of like, oh, you're getting to learn something new. Your job is not to get everything in the class. Your job is to learn from the class. So next time when you see something similar, you should be able to attack it. Some of you have this wrong notion. I think वो school का problem है. School में teacher taught you 10 things and you got all the 10 things and you're happy. But when you're for advance, if teacher teaches you 10 things and you got all the 10 things, you know what does it mean? The teacher is not teaching you anything, isn't it? I give you 10 and you got everything. What does it mean? I'm not teaching you anything. That's so think of it that way. It is a good thing if you're not getting something, but yeah, you should understand after I explain you though. So how do we do this? H is L. I don't want that, Ananya. I want dH by dt. I want to know at what rate is that thing falling down. Okay, someone got 40 by 9 pi. I'm not sure about the answer. Let's see, anyone else got something though. 40 by 9 pi, okay. Yeah, I also got 40 by 9 pi. We have two people who got that. Think, others, try. It's like I said, like I keep saying, really don't worry about the answer. If there are 5 steps, if you figure out 1 or 2 steps, you did a good job. Once you start solving, you should think like, oh, मैंने भी ऐसा ही start किया था. After this, I didn't get an idea. I mean, if you can think of like that, then yeah, you are there. You're getting it. 60 degrees is the half angle. I gave the picture clearly there. If it was a full thing, I would have drawn it like this. I know my handwriting is bad. Still, you can clearly see it as an half angle. Okay, two people got the same thing. I don't remember the answer though. I just made up the numbers. Let's see. Okay, so you're saying the volume is leaking at a rate of 10 centimeter cubes. First, let's mine the data, okay? Let's see whatever data points I gave. Let's try to data mining. Perfect. So what did you give me? You said volume leaks at a rate of 10 centimeter cube per second. Great. So meaning if V is your volume, it is given in the question dV by dt is 10. Perfect. Next thing, he said when the length is 3 centimeters. Now, if you look at this cone here, this would be your radius. This would be your height. So it's a right angle triangle. So R is nothing but L sine 60. And what is he asking you? He is asking you H. Perfect. And L cos 60, H is nothing but L cos 60. So this is L by 2. That's the relation between H and L always. L is equal to root 3 by 2. Perfect. Great. So what is the volume? Volume V is 1 by 3 pi R square H. Actually, I don't need this. I need relation between H and R. I can do that directly from tan 60. You will see why I need that only, R by H. So we get R is equal to H into root 3. Perfect. Now see, this is what I keep saying. After reading the question, always look at the options, like, what is being asked. Question may they gave rate of change of volume and they want rate of change of height H, meaning they're interested in H. They don't care about the radius. They don't care about length. L is given, but they don't care about all that. Great. So perfect. So I need to get this V. Now see, look at here. There are two problems here. There's an R here, there's an H here. Both are variables. R is also changing, H is also changing. So I don't want to deal with both of them. I'll convert all into one variable, which is H. 1 by 3 pi. R is how much? H root 3. This is what we are trying to do. So I got the entire volume in terms of pi H cube. Interesting. The 3 goes off. Clear with this what I did. So this is what I was saying. See what I know. You gave me dV by dt. And what are you asking? dH by dt. Means you don't want R, you don't want L. So just remove all these guys, get me V in terms of H. And then let's differentiate with time. Then this guy will be dV by dt. And then this would be pi dH cube by dt. And the left hand side is 10 centimeter cube per second. That's given in the question. And this is pi, and H cube ka differential is 3H square. And then differentiate whatever is inside there, dH by dt. That's what I need to find. And then dH by dt is 10 by 3 pi h square. Perfect. But I don't know what is h. But in the question it is given where L is 3 centimeters. So I need to find h. So I do need actually. So this is L cos 60 is h. So h is L by 2. So then this is 3 by 2. So when L is 3 centimeters, h was L by 2, which is 3 by 2. So just take this and dump it here. That is 10 by 3 pi. That's 3 square by 4. That's 40 by 27 pi centimeter per second. You guys missed an 3 somewhere. Check, or maybe I messed up the calculations. Again, what did I do? I know dV by dt, and I know volume is 1 by 3 pi r square h, but r I don't know. So I will write r in terms of h. I get that from tan 60. I substituted there. I got volume in terms of h, which has a pretty good equation. Then I differentiated it. And then in the question, it is given when L is 3, when L is 3, h is 3 by 2. So I dumped it and I got this. Anyone else got the same? Please check the calculations until unless I goofed up. I don't know. People got 40 by 9, 20 by 9. No one got 27 though in the denominator. Okay, Ahana says mine is right. All clear with this? Yeah, you did not square. There, so that's how we can do rate of change. You got a bit of an idea there. So there, so please make sure to go through the entire today's class. I think you should go through everything. You can see it's not tough, but it is a little different. So make sure to go through the stuff. So there we started with the chain rule today. Chain rule was fine. There's nothing there. It's a function of a function, but telling you again, it might look easy, but please do it again. People do get confused, right? You have to get used to it, do it once or twice. And then, this was the main question. I think question 13, you guys should definitely spend some time, actually take a rough paper and just do the whole thing. If you're really confident, मुझे सब आता है, कर लेना then 5 minutes में. If you're that confident, you should do it. Get the whole thing end to end, and then you say, oh, I got it. Then it is good. Don't tell it in your mind, oh, I got it. Prove it. Put it on a paper. And the rate of change is fine. So that's a bit about it. So next class when we catch up, right, we'll continue from here. We will do something called maxima, minima, right? Can you do DH can be taken as Han, and you can do that, right? So next class we'll do maxima, minima. That's quite an important thing. And that would be the last part in differentiation. And after that, we'll go ahead with integration. But yeah, maximum minimum will take, I think, 1.5 class. But that will be quite useful. We are going to use it a lot. Okay, with that, we'll wrap up for the day. And do remember, there's a test online till Friday, so make sure to give it. So we'll catch up again on Wednesday, same time. So any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys Wednesday. So yeah, take care, stay safe.